Hello everyone and welcome. I'm the Retro Repair Guy. Have you ever wanted to restore that old radio or game console, or saw something in a thrift shop that brought back memories and thought about how cool it was when you were a kid and wish you could see it working again? Vintage equipment repair is not for everyone. It's like restoring an old car. It's something you have to have passion for and patience. But it does have its rewards. Besides the nostalgia and bringing you back to better times, electronic equipment was often like old cars. They were robust, high quality units built to last with much larger components that were easier to fix. In this new series, we'll focus on restoring vintage electronic equipment of all kinds, including game consoles, computers, radios, tape decks, as well as review some of this gear. Through this series, I wanted to take you through the restoration process with a little more explanation that includes history and common issues while focusing on restoring the unit to its original state. In today's episode, I start with a very commonly restored unit, the PlayStation, or PlayStation 1 as it's often referred to. The PlayStation was released in December 1994 in Japan and almost a year later in North America and Europe. There are quite a few left out there, as Sony had reportedly sold nearly 103 million units. They manufactured the PS1 until 2004 and released the last game for it in 2006. Now, 1994 was also when much of the electronics were manufactured in Japan with a total quality approach. Still today, the Made in Japan tag means superior quality and long-lasting products. But back to the original PlayStation, while there were many revisions made to the interior components, two significant versions were made. A bit like today's console and slim, the newly redesigned one was called the PS1. So although we refer to the original PlayStation as the PS1, the original was called PlayStation and the redesigned 2000 version is the PS1. At the time, its biggest competitor was the Nintendo 64 with nearly 33 million units sold. The PlayStation boasted 2 megs of RAM and 1 meg of VRAM or video RAM. But the one specific thing that set it apart from the Nintendo 64 was its games were a whopping 650 megabytes compared to the cartridge-based console that had games that were anywhere between 4 to 64 megabytes. It was costly and challenging to develop these cartridges, and their limited storage capacity constrained the game's content, while the PlayStation allowed for 3D graphics and music. This led third-party developers of the Nintendo 64 to switch to the PlayStation, such as Square Enix, whose Final Fantasy VII and Dragon Quest VII games were initially intended for release on the Nintendo 64. The specific model we're looking at today is the SCPH7501, giving it a manufacturing date of late 97 to 98. It's classified as a Revision C hardware and made for the US and Canada market. The previous revisions had issues with the CD player, which caused problems with the FMV or full motion video. FMV is when a player experiences skipping or choppy sound during an animation. Revision C hardware, starting with the 5001 series and on, corrects this issue. The fix is achieved by reinforcing the lens carriage. Inside this hardware revision of the PlayStation, you'll find 4 components: the main board, the power supply, the CD unit, and the joystick ports. Today we'll be focusing on a common failure, the power supply. If you got a dead unit as I have here, the very first thing you'll want to look at is the power supply board, or as it's referred to in the service manual, the power block. Here you'll want to look at 2 particular components, the fuse and the capacitors. The capacitors are aluminum electrolytic capacitors. Electrolytic capacitors means there is liquid inside that can leak and cause damage or short circuits. You'll want to inspect the board for any burns or liquids. Take down the values, unless your capacitors are too foobarred.
We're gonna get foobar now.
What the hell's foobar?
You'll see.
And look something like this, then you can refer to the manual. It's never a bad idea anyways, in case somebody's been there before. Now, even if you don't see any damage, this is a power supply and it's 20 years old. There are only 5 capacitors on the board, the smallest costing 50 cents, the biggest one costing $2. For less than $5, let me tell you, you'll buy yourself some peace of mind and some time so that you know that for years to come you won't have any damage on the board. I always replace the capacitors no matter what, and I can't stress this enough. It takes an extra minute to remove the fuse and visually inspect it. The size of the fuse should be a 250 volt, 2 amp fuse. Also, test it with a multimeter for continuity. Alright, let's go ahead and remove the capacitors. I like to use a desoldering pump. You can use a desoldering gun if you wish, but I think it does a pretty good job. With the capacitor removed, I then proceed to clean the board. I like to use 99.9% alcohol as it doesn't leave a residue and evaporates quickly. I make sure to clean up any residue left from the old capacitor, as well as any residue left behind by my soldering. Now the board is ready to install the new capacitor. Now you can see this was truly manufactured in Japan. It's an SMG capacitor which was made by Nippon Kimicon Corporation in Japan. Now when replacing capacitors, I like to work with Nishikon capacitors. Nishikon is also a highly respected Japanese manufacturer, so you know you're getting a quality product that should last. Whatever you opt for, it's important to note the size and length of the capacitor. If a capacitor is too long, for example, it could prevent the case from closing. And if it's too large, it could prevent other components from going in. Now, if you've gone ahead and removed the capacitor and don't remember what side it goes in, there's a negative and a positive side. The semicircle here indicates the negative side. Installing the new capacitor is pretty straightforward. Simply put the legs through the holes, make sure it's seated properly, spread the legs a little bit to make sure that it holds in place, and then solder. I'm soldering with 0.8 millimeter 6040 Rosen core solder. When soldered, cut off the extra metal legs. Make sure you don't cut too close to the soldering points. And that's all there is to it. I'll solder the rest off camera. I quickly checked the two 560 microfarad capacitors I removed. This is a cheap little machine, but it does the job. For one of the capacitors, I couldn't even get a value, and for the other, I got a value of 620 microfarads and an ESR of 4.4, which is basically resistance. ESR changes as components age, and this is not good. We can compare the readings to a brand new one, 574 microfarad and an ESR of 0.25. The new capacitors should last for years to come and will certainly give this old unit a new life. Now, many of you may not like me for doing this, but I like to restore things to the original state. This board clearly has a mod chip. It's very hard to make out, but in this case it's a 12C508, a very common chip that was used to circumvent the copy protection and region coding. I'm not against modding, but I can see this is very old and poorly installed. Before removing, I checked the installation procedure with this particular motherboard, the PU22, and it did not call for removal of any components. It was a straight solder to solder point job as you see here. Now I must apologize. I seem to have pressed pause when I recorded and vice versa. I did that like 5 times, by the way. I inspected each point where the mod had been soldered and cleaned it all up. I also wanted to show you how to clean the laser, so I reshot that. Now if you don't have 99%, you can still use 70% rubbing alcohol. Just take a cotton swab and the alcohol and gently rub it onto the laser. I also managed to salvage some footage of me putting the unit back together while I thought the camera was on pause. Let's take a look. Alright, well for this very first video I'll end it here. If I even get 1 subscriber, I'll make more of these informative videos. I'll be posting them on both YouTube and Rumble at the same time, so please leave me a comment in the comment section and let me know if you'd like to see something specific. And if you like the video, please give it a thumbs up or Rumble, and don't forget to subscribe and select notifications so you'll know the second I upload a video. I'll be back soon with some more retro repairs, and until next time, thank you for watching.